Assalamualaikum and hello everyone. So for this week's lecture, we are going to learn chapter 9, Simple Harmonic Motion. So in this chapter, we are going to have 3 subtopics, 9.1, 9.2 and 9.3. And we'll go to the first learning outcome. It's the learning outcome for the first subtopic. It's kinematics of linear motion, simple harmonic motion. So the first objective is to explain the meaning of simple harmonic motion, and then the second one is to look at the problems that relate to displacement in simple harmonic motion. So the motion will have a displacement and the symbol is y, and the motion will be in a form of, will be translated into a graph of sine function or can be cos. So this is the basic equation. The third learning outcome is to derive the equations for velocity, acceleration, kinetic energy, potential energy, and the last one is, the second last is to emphasize the relationship between the simple harmonic motion, energy and amplitude, and the last one is to apply the equation for velocity. Acceleration, kinetic energy and potential energy for simple harmonic motion. Okay class, so this is the definition of simple harmonic motion. So basically it is a motion that is periodic. Okay, so we'll see what is the meaning of periodic motion without loss of energy. So the motion does not have any loss of energy, and when an object is moving with simple harmonic motion, the acceleration of the object is directly proportional to displacement. So we can see from this equation, A is directly proportional with y. Y is displacement. Okay, and it is acting in opposite direction. So opposite direction is going to be represented by the negative sign in this equation. Okay, in simple harmonic motion, we have a few terminologies that we have to know in order to solve the problems and to understand the concept. So the first one is the displacement. Okay, we have an object moving with simple harmonic motion. So for the displacement, we choose y as the symbol. We are not using x, we are not using s. Okay, so what is displacement? So it is the distance from the equilibrium position. So later on I will explain what is equilibrium position. It is the most stable position of the object. And then we have the term amplitude with symbol A. So basically amplitude is the maximum displacement. Okay, it is the maximum distance from the equilibrium position. And we have the term period. I believe you still remember what is period. It is the time taken for one complete oscillation. Okay, and then we have the equation for period is T is equal to 2 pi over omega. Okay, please remember omega is equal to 2 pi f or 2 pi over T. So omega is angular velocity, and we have one more term, that is frequency, is the number of complete cycles performed in 1 second, and the equation for frequency is 1 over period. So the unit for frequency is hertz. And this is the example of simple harmonic motion of simple pendulum. So as you can see here, okay, the pendulum is oscillating, or the object here is oscillating. So this is the displacement. It is moving to the right, it has positive displacement, and if it's moving to the left, it is having negative displacement. So we have a bit faster, a motion of a bit faster. Okay, positive, negative. So this is simple harmonic motion of pendulum. And this is the example of a horizontal simple harmonic motion. So as you can see here, we have equilibrium position at the center, and let us focus only at the graph of displacement against time. Okay, so we only have one graph. So as you can see here, when the car is oscillating, okay, it will generate a graph of sine function. Okay, so this is the equilibrium position, and this is the amplitude. Amplitude is the maximum displacement, and from this motion of this car, it will generate a graph of sine function. Okay class, so as you can see here, when the car is moving to the right, so the graph is at positive side, and when the car is moving to the left from the equilibrium position, the graph is at it is a negative displacement. So basically this is the graph of displacement. And again, if you can see here, so the car is moving to the right. Okay, it is to the right from the equilibrium position, so this motion is displacement is positive. And if it is moving to the left from the equilibrium position, so the graph of displacement is at negative side. So your value of y is going to be positive and negative. You have two possibilities. You can see here, this is the example of vertical pendulum, vertical spring. So it is oscillating up and down. Okay, one more time. So we have equilibrium position at the middle, and for this motion, as you can see here, the motion is above equilibrium position, so the amplitude is going to be positive, and when it is moving downward or below the equilibrium position, the graph is going to be negative. So let's substitute the equation.